Welcome and study with Tanzania Institute of Education.
Hi students, welcome in the physics lesson. I am teacher Jafari and I am going to teach you the topic named forces in equilibrium and particularly in the subtopic named moment of force. Dear student, now get prepared. Take a pen, take an exercise book, and then sit where you are, ready to participate and share for all of things which we are going to discuss. This topic is specifically for Form 2, but it is a good revision for the Form 3, Form 4, Form 5, and Form 6. So please, 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 I insist for every one of us to make sure that you write on every aspect for which we are going to discuss. Dear students, as I have said, this topic is very useful into our life. In our everyday life activities, we just apply force to open or close doors or windows. Again, when force is applied to the bicycle pedals, I know everyone knows the bicycle, and we ride the bicycle. The force which you apply to the bicycle, to the pedals of the bicycle, they cause the wheels to rotate. Now, can you guess what causes the objects to turn? Yes, my student? Of course, yes, you are right. It's a force. Force is the one which causes object to turn. But now, this force which causes object to turn has a specific name. The main question of us here now is to note what is the name. What is the name which is a special name which we can assign for this kind of the force. Write please this question, that what is the name for the force which cause objects to turn? This is a very important question of which if we know the specific name or the actual name which is the cause of object to turn, now we'll be in a good position for our discussion today. Now, to know the clear concept of this, let us try to make a revision on what we learned for the case of the force. I think you remember, we said and we learned that we cannot observe or we cannot see the force, but we do see the effects of a force. Do you remember the effects of force which are almost occurring? Let us list them here. Some effects of force are like, we said, the case of compressing, of which we can say a compressing force, but also we are having the rotation, but also we saw the turning, etc., etc. We saw several kinds of the effects, but I mentioned a few of them. We saw this one. Now I am going to demonstrate some of what we said, that we observe the effects of force. Once we're saying about the compressing, let us see. If you are having an object like this, I think my student will know this, this is a rubber. Now, if we want to compress a rubber, means you can just do like this. You are applying force to a rubber, and it means now you are observing the effect of applying force to a rubber, means which is compressing it. Once we are saying about rotation, we can see I have this mass. If I apply a force to it, I can make this mass to rotate like this. It is rotating, like how a bicycle's pedals do rotate in general. But we said about the case of turning. The turning cases is like when we open a door or close a door. We just see a door is just turning to a point which is fixed. We are going to know what that point. So get stayed and relax. We know in detail what kind of that point we are saying. Now, after looking these effects, I think we are now familiarized and we have remembered what were some of the effects. But our main concern today is just now to see the effects which are according to the turning. So let us see some effects of the turning point. Sorry, our subtopic is still there, that we are under moment of force. Moment of force. So we have to see the examples of turning effects of a force. Turning effect of force. When we are saying about to turn, so some of the examples of this may be like if a person apply a force to a spanner, just either to tighten a nut or to untighten a nut. So we are applying a force to a spanner. But also, apart from this, if someone try to remove the bottle's opener, there you are applying the turning. There is a turning there. So we can say removing a bottle, removing bottle opener, bottle's opener, or let us say it's a bottle's cap. Sorry, I mean bottle's cap, or whether it's a cap or whatever. But if you are removing that cap, bottle's cap, using bottle opener, But also try to see if someone is just opening or closing a door, you are applying force there. So we can say here that applying force to a door, we can say it is it's a door knob. We are going to discuss what that knob, a door knob to open or close a door. Apart from this, we are having also, let us say, a person who is applying force to a rim to turn a car steering. I think every one of us know the car. A driver, if he's driving, means upon to turn, whether you want to turn left or to turn right, you apply force to a rim or steering. So we can say applying force to a rim so as to turn, so as to cause the turning of the steering, to turn a steering, etc., etc. So all of this, and there's so many more, they are just examples of the turning effect of force. Now, the discussion you have made here, whether you are applying force to a spanner, whether you are removing bottle's cap, using bottle opener, or whether you are applying force to a door or knob, or whether you are applying a force to a rim to turn a steering, all of these are what we are calling moment of force. Therefore, moment of a force is the ability of a force to make something to turn or to rotate. We can write this definition that moment of force is the ability of a force to cause objects to turn or rotate. As we have seen from all of those effects which we have discussed, we are describing what we call about the moment of force. Moment of force can also be referred to as a torque. That is another name of which we can consider a moment of force. Let us write it, that moment of force can be referred, or we can say, moment of force is also referred as a torque. So once you see this word torque, once you see this moment of force, they are the thing which mean the effects, ability of a force to cause the object to turn. Now, the question to ask ourselves here is, now this moment of force we have seen, what are the things it depends? So let us write this as a question to ask ourselves, that what do moment of force depends? This is a question to ask. Now, to answer this question, let us have this activity. As we have said that to recall a moment of force, that the ability of a force to cause objects to turn, I have a meter rule here. So even you, where you are, you can have something which is just a rod or whatever thing. But also I have a mass here, a mass. So if I hold the meter rule in this case, this point can be regarded as a point of suspension or as a fulcrum. I'm going to see it in detail, but my case is now just to see that this is a force attached to this meter rule, and then I'm going to just to see, to change the positions of the masses over the different positions of this ruler. Then you're going to see what happens. Initially here, the mass is near to a pivot point. You see? What you see here? A ruler is just straight. It is just straight. Now, suppose I shift this mass to a certain distance here. What you see? Student, do you see? What are you observing? I think you'll see here there is something. A ruler now is now starting to turn. There is a turning point here. But suppose I put them here far away. What do you see? Are you observing here? Yes. So you see here, there is much turning point. Yeah? There is much turning point. So from this, what we can conclude? We can conclude that the moment of force is just depending on first the force, and the force is this one. You see, this force, I mean, these masses are the force, in fact. But you also observe that as I increasing the distances, also the moment of force is just increasing. So we can simply say now that the moment of force depends on the mass, and this mass we can call them as a force or weight, but it depends also with the distance. But this distance we have seen, as you see, the distance we have seen, it should be perpendicular with these masses. So we can now clearly have this, that we can clearly have this concept now that the moment of force, moment of force depends to the force and distance, and this distance should be perpendicular distance. But to be clear now, we have to define clearly the relationship of this force and the perpendicular distance. They are in what manner? So as you see here, we have observed that as the distance increases, also the turning point also increases. As it increases, the turning point also increases. So this relationship is in such a way that it has to be in multiplied form. So we conclude by saying that now moment of force, that therefore moment of force is defined as force times perpendicular distance. Perpendicular distance. Mathematically, this one can be represented as, if you wish to assign a moment of force as m, and force to assign with its symbol as f, and its perpendicular distance to use the symbol of d. So mathematically, we can write it as follows: that moment of force m should be equals to the force times perpendicular distance, where we have assigned this m to be moment of force, F equals to force, and D equals to perpendicular distance. Perpendicular distance. Now, dear students, in order to memorize it properly, you might put it in a triangular form here. In order to memorize it properly, you can put it in a triangular form here, that here we are having moment of force m, and here you are having, as since it's the product of the force times distance, so here is force and here is distance. Means from this, what you can interpret here is that moment of force m is equals to force times perpendicular distance. But if you want to obtain what is the force, you can hide it here, that force is going equals to mass divided by distance, mass over distance. But someone also might be in need to know the distance. If you ask to calculate the distance, that now distance, if you want distance means you hide it here, then you get that distance is equals to mass over force. Equals to mass over force. Now, I said previously that once you are dealing with this moment, there is a point where a force is being acting. What is that point? That point, as I said previously, we name it as a fulcrum, or others do use it, name it as a hinge or a pivot. Let us write this. Let us write this. That the point where force acts in moments, is called the fulcrum. Is called the fulcrum, or others do say the word hinge, or others use the word pivot. All these are the words which are used to describe that point. Now, dear students, after knowing what is the moment of force, let us now see the SI unit of the moment of force. SI unit of moment of force. Moment of force. To get the SI unit of moment of force, it is just to define what are the units of the dependence of the moment of force. As we said, that moment of force is just a product of the force and perpendicular distance. What is the units of force? You remember? That is what? Yes, exactly. Is Newton. And what is the unit of the distance? You remember? Is what? Exactly. It is meter. So the SI unit of force, moment of force, excuse, that it is termed to be Newton meter. Newton meter, and is written in this case. But if you want to write in a symbol case, it is capital N and a small letter m. This is the SI unit of the moment of force. Now, my students, I think now you are now clearly in the position to answer. To answer any kind of the question that involves on the case of the moment of force. Now, let us take a short break, and then we'll be back to do one example of the questions which might arise. Student, now this is an example provided. A question we have is asking us that what is the turning effect of the force in the diagram about the nut at a point P? We are having point P here. This is a nut and this is a spanner, in fact. So whether a mechanic is applying force downward. So our case here is first to analyze the data. Data given. Firstly, we are having a force, of which force we can write its symbol as capital F equals to 10 Newton. But this 10 Newton is located 20 centimeter away from point P, or from this from the center of a nut. So this is a perpendicular distance. Perpendicular distance. We can write its symbol as D equals to 20 centimeter. But this 20 centimeter is not the SI unit of this of this quantity. Dear student, you remember? Now we have to change this into its SI unit. What is that? 20 centimeter is going to be equals to? Yes, good. Is 0.2 meter. Now we are after turning effect or moment of force. Now, moment of force, we can write its symbol as M now is equals to what? The parameter which we are finding here. So we can now write a column here for formula and the calculation. Formula and calculation. That from our discussions, we have said that the moment of force, which is m, is the product of the force and the perpendicular distance. Now, m equals to force times d. Moment of force equals to force times the perpendicular distance. Now, the force we are having is 10 Newton. Now, is equals to 10 Newton times our perpendicular distance provided here is 0.2. 0.2 meter. Now, it comes a matter of calculating that 10 Newton times 0.2. What is the answer? Yes, good. That now m is going to be equals to 2. But what are the unit? We are having Newton and a meter. Here you have to see where does the turning point is. I mean, where the direction of the turning is where. If you see here, you find that this is in the direction of the clockwise. So we can say in clockwise. So you can conclude by saying that moment of force is 2 Newton meter. Dear student, I think you see how easy the questions are. So to broaden your understanding and to measure yourself to find how far are you for the concepts we have discussed today, I'm going to give you the exercise which is going to be seen here on the screen. Dear students, we have come now to the end of our lesson. Thank you very much. I think you have enjoyed your lesson, and see you next time. Bye.